Okay, today I'm just going to be working through some of these higher level quadratic questions. These are not the most intuitive. Sometimes it's not as obvious that you will need to use a quadratic for these sorts of questions. For example, we know that the sort of hallmark of a quadratic is this x squared term. We know that we're going to need to solve this the way we solve quadratics, but some of these questions in this booklet are not as obvious like we can see here. But I'm just going to work through them, show you how to do them and see how we get on. So this question 1, we've been given a right angled triangle. We know that all the measurements are in centimetres and the area of the triangle is 27.5 centimetres. So we're going to highlight this. We must work out the shortest length of the triangle and you must show all your workings. So we can see that this one is going to be the shortest length. So the key to questions like this, where maybe we mightn't be as sure where to start, always look at the actual numerical information that you've been given. You've been given that for a reason. So here we've got the area. We got the area and some quantity for the area. We know that the area of a triangle is half the base times the height. This is where we're going to start. We know that we can sub our values from this triangle in and we're going to get 27.5. So let's do that first and foremost. We're going to do 1/2 the base, which is x minus 2, times the height, which is x plus 4. And we can see here that this is going to form a quadratic. We'll multiply this by this and this will give us that x squared term. We'll have some combination of x terms and then we'll have a constant numerical value. So let's work this through. What I'm going to do for now, I'm just going to ignore this half. We can carry this through our workings. So let's first and foremost expand these brackets. We're going to get x squared. We're going to have a minus 2x. And then we're going to have 4x. And we're going to have minus 8. So we can simplify this and we'll get x squared. This will become plus 2x because we've got 4x minus 2x and minus 8. And now let's not forget, we've still got this factor of a half here. So what this will become, if we sort of expand this out, we'll have a half x squared plus x minus 4. So you just halved all of the terms in this bracket here. Okay, we know that this is equal to 27.5. What we need to do to solve a quadratic, we know that the root of the quadratic, if we draw out what we expect this shape's going to look something like this. All our quadratics have this U shape. We know that the roots here, we find them at when y is equal to 0. So we need to set this equation equal to 0. At the minute it's equal to 27.5. We don't want that. So what we can do is we can say a half x plus x minus 4 minus 27.5 is equal to 0. And then we can just simplify that. So we're going to have minus 4 minus 27.5 is going to give us half x squared plus x minus 31.5. And this is equal to 0. Now, this doesn't look like the nicest thing in the world to solve. We've got this factor of a half. We've got, again, this sort of decimal value here. What we can do when we have any equation that's equal to 0, we can multiply both sides of this by 2. And this is still equivalent. We've multiplied both sides by the same thing and we're still going to have this factor of 0. So what we can say is that this is equivalent to x squared plus 2x minus 63 is equal to 0. And then we want to look for factors of A times C that add up to B. So we can use either our grid method for this, or we can just use our regular method for solving quadratics. I know that 9 minus 7, if you multiply those together, that will give me negative 63. And if we add those together, it'll give me 2. So I'm going to split up this 2 term into 9x minus 7x. So I'm going to have x squared plus 9x minus 7x minus 63 equals 0. I'm going to factorise this. I'm going to take out an x term here. It's going to give me x plus 9. And then here, I'm going to take out a negative 7. And this is going to give me x plus 9. So this gives me x plus 9 as one of my brackets, and x minus 7 as another one. And then we just solve those as normal. We're going to set both of them equal to 0. So if x plus 9 is equal to 0, x is equal to minus 9. And then if x minus 7 is equal to 0, x is equal to positive 7. So to work out the shortest side of the triangle, we just need to sub those values in. Obviously, here, one of our x values is negative. If we use this value here, we say minus 9 minus 2 is equal to minus 11. We obviously cannot have a negative length of a side, so we're going to need to use the positive value of x here. So our other value was x is equal to 7. So we know that this length here is going to be equal to 7 minus 2, which is 5, and that is all. And now on to question 2. This one is 5 marks, so we're expecting this is going to take quite a few steps on our working out. So we've been given 2 shaded shapes A and B. Shape A is formed by removing a sector of a circle with radius 3x minus 1 from a sector of a circle with radius 5x minus 1. So we can see that here. This is our 3x minus 1 and this is that sector. And then if we add this 2x, this will give us 5x minus 1 and it will give us this whole sector here. So we know that the area of shape A is equal to the area of shape B, and we need to find the value of x. So we again just start with what we know. We know that the area of a circle is equal to pi r squared, and we mightn't know the area of a sector, but we know that a sector is some fraction of a circle. If we slot loads of these around each other, they will make up a circle. So, do we know what fraction of the circle this sector is? Yeah, we've been given this angle. We know that this is 45 over 360. That's the proportion of the total angles in the circle. Pi r squared. And that will give us the area of this sector. Again, that's because we know that it is this fraction of a total circle. So if you work out the area of the circle and multiply it by that fraction, you will get the area of the sector. Okay, so we can just start by working this through. So we know the diameter of shape B is 2 minus 2x. So therefore the radius is half the diameter. So that's going to be 1 minus 1x. And we know the area of this shape is pi times r squared, and that'll be our area. So a place that we need to be careful not to get caught out we cannot do 1 squared minus 1x squared. That is not how these square brackets work. This means you're going to multiply this bracket by itself. So what this is going to look like is pi. Again, we can do the same thing as we did with the half and just kind of ignore this for now, as long as we carry it through and make sure we don't forget about it. This is going to be pi 1 minus 1x multiplied by itself. And we need to expand this out. So 1 times 1 is going to give us 1. 1 times minus 1x is going to give us minus 1x. Minus 1x times 1 is going to give us minus 1x. And then minus 1x times minus 1x is going to give us positive 1x squared. Because we're multiplying a negative by a negative, it'll give us a positive. Okay, so now we just need to simplify this. We have pi, this 1 is our only numerical term. We have minus 1x, going to give us minus 2x. And then we've got this positive x squared term here. So I like to write these with my x squared at the front. You don't have to do this, but I feel it's easy to see what we're working with. And we have this plus 1. Okay, so this is a quadratic. We've seen these before. We know what to do with these. All this pi on the outside means is that we're going to multiply each term by pi. But as I say, we can kind of ignore it. I suspect this will eventually cancel out as we will be working with a pi here. So let's just leave that there for now. So we've done half of the question. What we need to do now is find the area of shape A, because we know that this is equal. So what we're going to have to do here is find the area of this total shape and then subtract from the area of this shape, and it will give us area A. So let's start with that. Let's work out this total area first. So we know that that is going to be 45 over 360 pi r squared. So what is our radius here? It's 5x minus 1. Again, we just need to be careful. I'm going to leave all these outside for now. We don't really need to worry about these. And we're going to multiply this whole bracket by itself. So by another whole bracket. So we can work this through. We're going to get 25x squared minus 5x minus 5x. And again, remember this will give us positive 1. And let's not forget this 45 over 360 pi term. So let's simplify this. We're going to have 25x squared minus 10x plus 1. Again, this is just a quadratic. We've seen these before. We're used to them. This is in a form that we know how to work with. Okay, so this is this total area here. Now let's work out the smaller area. I'm going to do this in a different colour. So we now want to work out this. The only difference here is the radius. As you can see, this angle applies to this whole shape. So we're just going to do exactly the same thing. 45 over 360 pi. This time our radius was that 3x minus 1. And remember, this is squared. So let's expand this out. We're going to get 9x, or 9x squared, that'll be minus 3x, minus 3x. And again, we'll get that plus 1. And this is all still multiplied by this factor, the proportion of the circle. So we can simplify that. We'll get 9x squared minus 6x plus 1. Okay, so again, we just got a lot of quadratics. To work out this area A, we said we would subtract this area here from the total area. And we can do that because they have this constant factor at the front. This applies to both of them. We can kind of just ignore it in our workings because that's still going to be there once we've done the subtraction. So, like I say, let's just sort of ignore that. We'll write it here, we'll make a note that it's there. What we really have here is 25x squared minus 10x plus 1 minus 9x squared. If we do minus 6x squared, that becomes plus 6x minus 1. And we can simplify this. So again, we keep this here because it applies to everything. We've just factored it out basically. We have 25x squared minus 9x squared. That's going to be 16x squared. We have minus 10x plus 6x. That's going to be minus 4x. And we have plus 1 minus 1. That's going to be 0. So this is the area of shape A. So our two important pieces of information here is this area of shape A and this area of shape B. And what we know is that they are equal and we need to solve for x. So I'm going to move on to a new page. Okay, so this is what we know and we need to solve this for x. So where I like to start, I'm going to cancel out any common terms. You can see here that we've got a pi on both sides. So what we can do is essentially divide both sides by pi. And that will factor out this pi term. So then what we're left with is 45 over 360. 16x squared minus 4x. And that is equal to x squared minus 2x plus 1. Then what we can do is take this factor 360 and multiply both sides. So we're going to have a factor of 360 up here and this will cancel on the bottom. And it might be so obvious why we do that, but remember this is a challenge question and this is some really tricky maths and I'll show you why we're going to do that. So we factored out this 360 on the bottom. So we have 45, 16, x squared minus 4x. And then we're going to have 360 x squared minus 360 times 2, which is 720 x plus 360. So you might think that we've just made this look worse, but we haven't because we don't have a fraction anymore, which is always good. Then what we just want to keep looking for is common factors that we can keep simplifying this down. So I know that 15 goes into all of these numbers, possibly even a bigger one. But you don't have to do everything in one go. We can start with 15. So 45 divided by 15 is 3. So now we've got 3, 16x squared minus 4x. 360 divided by 15 is 24. 720 divided by 15 is 48. And then again, I'm going to have this factor of 24. So This already looks much more manageable. Then we can check for any other factors. I know that 3 goes into all of these numbers. So really up here, I could have divided everything through by 45, but that wasn't the most obvious thing to see. It's okay to do things in steps. So let's divide both sides by 3. We're going to have just 16x squared now. We've gotten rid of this factor in the front, we've divided through. This is going to be 8x squared minus 16x plus 8. So this looks much more manageable. Now we can arrange this into a regular quadratic. So as I said earlier, we're going to want this side to be equal to 0 so we can solve it. So let's take everything here and move it over to the other side of the equals, where it will change signs. We have positive 8x here. We're going to subtract 8x from both sides. We're going to be left with 16x squared. Take away 8x squared. That will give us 8x squared. We have negative 4x here, and we're going to add 16x to both sides. That will give us positive 12x. And then here we have this positive 8. We're just going to subtract 8 from both sides. This will give us minus 8. And this is equal to 0. Now, we just want to solve this as always. Or if you like, you can simplify through again. I would quite like to divide everything here by 4. So we're going to have 2x squared plus 3x minus 2 equals 0. Again, remember, if we divide 0 by 4, it's still just 0. So can you see here now how we have taken this, made it into this? This is equivalent. As long as you do everything equally to both sides, it is equivalent. Now this looks much more manageable, like something we can solve. So again, you can do this however you like. You can do your grid method. I'm just going to do the bog standard, what I call the AC method. We want factors of A times C that add up to B. So A times C here is negative 4, because we have 2 times negative 2. I can see some factors that will add up to 3. I'm going to do 4 and minus 1. So we're going to split this 3x term up into 4x minus 1x. We're going to have 2x squared plus 4x minus 1x minus 2. We know that that's equal to 0. We're going to factorise this as always. I'm going to take out a factor of 2x. This is going to leave me with x plus 2. And here I'm going to take out a factor of negative 1. This is going to give me x plus 2. So our first bracket is going to be x plus 2. Our second bracket is going to be 2x minus 1. And we can solve this. Here, if x plus 2 equals 0, x has to be equal to negative 2. And here, if 2x minus 1 equals 0, 2x has to be equal to 1. X has to be equal to 1 over 2. So we've solved for x. We have these two values for x. So let's just double check the question and what it wants of us. We have to find the value of x. Okay, so let's think here intuitively. We had this length, 2x. If we use the negative value, if we say x is equal to negative 2, this length 2x would be equal to negative 4. We know we cannot have a negative value for length. There's just no such thing. So our value of x, we have to use x is equal to a half. And this is my final answer. So this is a lot of work for a 5-mark question. In fact, this is more difficult than most things I've ever seen on any maths papers, but the beauty with these 5-mark questions is you can get a lot of method marks. So if we see something like this, give it a go. Use the information you've been given in the question. Try and set up an equation. Try and solve it. Make sure we're doing everything really clear. Obviously, I've got much more than 5 lines of work in here, but I do have 5 clear steps. So just give things a go. Don't get intimidated. And the final answer, we can always find them. Okay, now on to question 3. We're being asked to solve this equation. We've got x squared equals 5x plus 24. And as I say, when we see this x squared, we know we're dealing with a quadratic. And we know that to solve a quadratic, we need this equation to be equal to 0. We want to find x when y is equal to 0. So, we need to rearrange this. What I'm going to do is I'm going to keep the x squared as it is, because I usually prefer the x squared to be positive. I'm going to subtract 5x from both sides, and then I'm going to subtract 24 from both sides. That will leave the right hand side of my equation being equal to 0. So then we just solve as normal. We're going to look for factors of negative 24 that add up to minus 5. I'm going to use 3 and minus 8. So I'm going to split the 5x up. We're going to have x squared plus 3x minus 8x minus 24. It's going to be equal to 0. We're going to factorise each half. I can take out a factor of x here. I'm going to have x plus 3 on the inside of my brackets. And I can take out a factor of negative 8 here. And then I'm going to have x plus 3 in this bracket as I did before. So then clearly our first bracket is x plus 3. And our second bracket is going to be x minus 8. Solving this, we can see that if this is equal to 0, then x must be equal to minus 3. And here, if this bracket is equal to 0, then x must be equal to 8. So finally, we're going to move on to question 4. We've been told that the curve C has equation y equals x squared plus 3x minus 3, and that the line L has equation y minus 5x plus 4 equals 0. We're being asked to show algebraically that C and L have one point in common. So, let's figure out what we have. This is obviously quadratic. We have this x squared term. Tells us it's a quadratic. And this is a straight line. It does tell us that in the question, but it's not as obvious to see. We can rewrite this in the form y equals mx plus c. If we keep the left hand side of the equation equal to y, we can add 5x to both sides and subtract 4 from both sides to give us y equals 5x minus 4, and this is in the form of a straight. So, to show that the curve C and line L have exactly one point in common, we need to visualise what that actually means. So let's draw a rough plot of what this could look like. We have this curve C and we have some straight line. There's going to be some point where these will intersect and they will share some coordinate. If we pick off the point that they share, this is going to have some coordinate x, y, and we need to prove that there's only one of those. We need to prove that it's not going to meet anywhere else. So, at this point here, as we've just said, there'll be a common x coordinate and a common y coordinate. We already have a function that expresses the y coordinate of both the curve and the line. At this common point, the y value of the curve and the y value of the line is going to be equal. So we can set these two functions as being equal. We're going to say x squared plus 3x minus 3 is equal to y, which is equal to 5x minus 4. Again, because they have this shared y coordinate, so at this point, both of the values of these equations have to be equal. So now we can simplify this. In order to solve a quadratic, remember we want the right hand side to be equal to 0. So we're going to subtract 5x from both sides. This will give us minus 2x here. And then we're going to add 4 to both sides. This will give 1 is equal to 0. So now, using our AC method, we're looking for factors of 1 times 1 that adds up to minus 2. 1 times 1 is 1. And some factors of 1 that add up to minus 2, we can use negative 1 and negative 1. So let's split this up. we're going to have x squared minus 1x minus 1x plus 1 is equal to 0. And we're just going to solve this as normal. We can factorise out an x here, which will leave us with x minus 1. And here we can factorise out a negative 1, which will leave us with x minus 1 inside the bracket. Then we can see one bracket will be x minus 1, and the other one will also be x minus 1. Therefore, solving both of these, we will get x equals 1 twice. This shows us that there is only one value of x that will satisfy this coordinate, where the y values are equal. There will be no 2 points that share coordinates, so they do not intersect anywhere, and therefore they have exactly 1 point in common, as required.